Good morning, teacher. Today I'm going to make a presentation on application of conic section in real life. Before I start my presentation, I want to introduce me and my group members. My name is Brian Fong Sen Jin, and my group member is Chao Jian Yu and Laurie Ren. So, what is a conic section? A conic section is a geometric shape that is formed by the intersection of a plane with a double nape cone. As you can see from this picture, it's basically multiple parts, right? Multiple angles that you look at the cone. So there are four primary types of conic section. The first one is circle. You have the ellipse, you have the parabola, and the hyperbola. They all have their own distinct characteristics.
So firstly, we have the infamous circle. The circle conic section can be applied in many aspects like clocks and watches. The hands on the clock and a watch move in circular motion and is precisely regulated to accurately indicate the time. And there are two equations for us to calculate the circle, which is the standard equation and the general equation. So here is a question related to circle. Find the equation of circle given center is -3 and 5 and radius of length is 4 units. So we just start the given value into the standard equation and we will get the final answer of 16.
So one of the type of conic section is ellipse. The ellipse is a straight circle. Its curved shape looks like a flattened circle. The ellipse conic section is used in elliptical mirrors such as telescope and binoculars. The ellipse shape should allow for the focusing of light or the correction of aberration in the optical system. This now is a part of formula of ellipse. These two formula look quite similar, but they have one difference, which is a square. When the a square is below the x minus h square, then the ellipse will look like this. And besides for this type B formula, when the a square is below the y minus k bracket square, the ellipse will look like this. And we also know we have to know that for the vertex, center, and focus were always on the major axis. This is a question related to ellipse. A 50 feet wide tunnel has the shape of semi-ellipse that is 6 feet high and a distance of 4 feet from either end. How high is the tunnel at section? Which we have to find this B. We know that the tunnel is actually horizontal ellipse, so we just simply apply the formula that's stated in previous slide. So after we substitute that value inside the formula, so we will get B equal to 11,066.
Next up of the conic section is the hyperbola. The hyperbola is a U-shaped curve that has two separate distinct branches. It looks like a U basically. So what do we use hyperbola in our daily lives? So it's mainly used in astronomy. It's used to describe the path of comets and other interesting celestial objects that do not follow elliptical orbits. So we have different type of celestial objects and comets, right? So not all of them follow the same orbit. So by using this hyperbolic orbit, those astronomers are able to predict the future or path of these objects. So they kind of know where they go and when they'll come. Yeah. So we have two formulas when we discuss hyperbola. So the main difference is we have a horizontal hyperbola and also a vertical hyperbola. They are basically similar, but you can see the U shape here is basically terbalik. One is on here, another one is here. So because of this, right, you have to use two different formulas, but they are quite similar. The only difference is the y-axis and the x is on the opposite side. See here is x squared over a squared minus y squared over b squared equals to 1. This one, you just basically flip the x and y. So it's y squared over a squared minus x squared over b squared equals to 1. So you can see in this case, the a will be on this x-axis. But in this one, because you flip it over, right, the a will be actually on the y-axis, as you can see here. The b as well. See the b at first at the y-axis. But because when you flip it over, the b, it changes the position. So it's basically quite similar. It looks quite confusing, but it's actually quite simple. So this is the question related to hyperbola. It looks quite confusing, but it's actually quite simple. So an explosion is heard by two stations, 1,200 meters apart, located at F1. The coordinate for it is -600 and 0, and F2 600 and 0. If the explosion was heard in F1 was 2 seconds before it was heard in F2, identify the possible locations of the explosion, and we should use 340 ms as the speed of sound. So we have 2 points, F1 and F2. So the main difference is how long it took for them to hear. So the first one was F1 was heard in the speed of sound, which is 340, but F2 was heard 2 seconds slower. So you have to times 2. And the 680 ms is basically the difference. It's not how long it took, it's 680 more m over s. So now we just do a diagram. We write the explosion. and then we split it into two stations, station A and station B. When we draw the arrows, we know that the formula PF2 minus PF1 equals to 2A. So we already drew it out already. We extend the arrow that says 2 seconds. So what we do here is, as you can see, the formula here, PF2 minus PF1 equals 2A. We sub in the formula. So we know that PF2 minus PF1 equals to 2 times 340. So you get 2A equals to 680. And you divide 2 on both sides, you get 340. So as we follow up from the previous slide, as you can see, because we drew it out, right? Basically, the explosion is on a hyperbola with foci being F1 and foci on the branch closer to F1. This is because the explosion is nearer to F1. As you can see previously from the slide, it's closer to the coordinate. So we have A equals to 340, C equals to 600. What we need to do is find B. So we know the formula is A squared plus B squared equals to C squared. We already have our A, and we also have our C. So all we need to do is just sub in everything. We'll get B squared, which is 2,444,244,400. And then we sub in our formula, which is x squared over a squared minus y squared over b squared. We use this formula because we know this is a horizontal hyperbola. So we just sub in all the values, and this will be our equation. This will be our answer. So the equation to find the possible location of the explosion is x squared over 115,600 minus y squared over 244,400 equals to 1. Moving on with the next conic section is the parabola. Parabola is a U-shaped curve that can open upward, downward, left, or right. So the difference is the hyperbola has two U's, but it only has one. So this is actually used most in the civil engineering aspect because parabolas are used to design bridges, arches, and suspension cables. The inherent strength of the parabolic shape makes these structures more stable and support heavy loads.
For the formula of parabola, there got two types of parabola. There got two types of formula of parabola. For the first formula, the parabola will either open upward or open up downward. For the second formula, the parabola will either open to the right or open to the left. But how can we identify whether the parabola is open outward or open downward? We have to look to the formula P. When the P is positive, then that is open outward. When the P is negative, then that is open downward. Besides, we can get the vertex from the formula. When this is the question that related to the parabola. A bridge shape like a parabolic arc has a horizontal distance of 20 feet, which is this, and the center of the highest point and the height is 5 feet, which is this, above the ground. What is the height of the bridge at the point of 5 feet from the center? From this, we know that the parabola is actually open downward, so we have to apply this formula, and we can substitute the vertex 0, 5 coordinate inside the formula, then we can get the standard equation of parabola, but we have still got the unknown P. To find the P, we can just simply substitute 10, 0 inside the standard equation of parabola, and we can get the P equal to 5. And we also know that vertex is 0, 5, and P is equal to 5. Then we can just simply substitute this inside the equation. Then we can get the equation of standard equation of parabola. Okay, to find the height of the bridge at 0.5 feet from the center, you can see this is the origin central. Then from the 5 feet. So the thing that we only don't know is y. So we can just simply substitute this coordinate inside the standard equation of parabola. Then we can get y equal to 3.75. Then this is our final answer.
So before we end the presentation, I will share some of the application of conic section in our daily life. For astronomy, conic sections are used to describe the orbits of celestial bodies. Besides, conic sections also used in navigation. Conic projections are used in cartography to represent the Earth's curved surface on flat maps. And before we move forward to conclusion, there are the last application we would like to share about conic section, the use of conic section, which is mathematics. Conic sections are essential in geometry and algebra. It is to study the properties of curves and their equations. So finally, the overall conclusion is, in summary, conic sections with their versatile shapes and mathematical properties are not just theoretical constructs, but also a powerful tools applied across a wide spectrum of practical fields, making them an integral part of understanding and shaping our world. That's the end of our presentation. Thank you for your patience.